Ever wondered how a machine as complex as a computer works? With all the advanced applications and the millions of tasks a computer performs in a split second, it's easy to forget that at its core, a computer is simply a system that processes data. But how does this process happen? What happens inside the sleek, fast device you use every day? In this video, we'll break down the intricate details of how computers work, from the smallest components inside to the powerful programs they run. By the end of this video, you'll have a solid understanding of how a computer functions, processes information, and executes tasks that we rely on daily. Stick with me, and let's dive into the inner workings of a computer. 1. The basics. What is a computer? At its most fundamental level, a computer is a device that takes input, processes that information, and produces output. It's a tool designed to execute a wide range of tasks, from simple calculations to running complex simulations. But let's go deeper. A computer is made up of a variety of components that work together seamlessly to carry out these functions. The three most crucial parts are input devices. These are devices we use to give commands to the computer and input data. Examples include the keyboard, mouse, microphone, and touchscreen. Output devices. These devices allow the computer to communicate the results of its processing back to us. Common output devices are the monitor, printer, and speakers. Processing unit. This is where all the work happens, the computer's brain. This unit performs the calculations and decision-making that allow the computer to function. Every computer, no matter how big or small, operates on the same basic principles: receiving input, processing it, and providing output. But how exactly does each part work, and how do they all come together? 2. The Central Processing Unit, CPU. The CPU, often referred to as the brain of the computer, is the most critical part of the machine. It's responsible for interpreting instructions and carrying out operations that make a computer run. The CPU processes data by performing thousands, sometimes millions of instructions per second. The process inside the CPU can be broken down into 4 steps. Fetch. The CPU retrieves an instruction from the computer's memory, RAM. Decode. The instruction is then decoded, meaning the CPU figures out what the instruction actually means and what needs to be done with the data. Execute. After decoding, the CPU performs the necessary calculation, logic operation, or data transfer. Store. The result is then stored, either in memory or in another location where it can be accessed later. Each of these steps happens incredibly fast, within nanoseconds. For example, in a modern CPU, billions of instructions can be executed per second. The performance of the CPU depends on various factors, including clock speed, measured in GHz, the number of cores, and cache size. A higher clock speed and multiple cores mean more tasks can be executed simultaneously, making the computer faster and more efficient. 3. Memory and storage. While the CPU handles processing, it needs storage to hold both data and instructions. This is where memory and storage come in. RAM, random access memory. This is a temporary type of memory that stores data that the CPU is actively using. When you run an application, the operating system loads the program's code into RAM, and the CPU can access it very quickly. RAM is fast but volatile, meaning that when the computer shuts off, all data stored in RAM is erased. Hard drive SSD storage. While RAM is used for temporary storage, the hard drive or solid-state drive, SSD, provides long-term storage. This is where your files, operating system, and programs are stored. Hard drives use magnetic disks, while SSDs use flash memory, which is faster and more reliable. One key difference between RAM and storage is the speed. RAM is much faster than hard drives and SSDs, but it only holds data temporarily. Storage devices hold data permanently, allowing you to save files, install software, and keep your system's operating system intact. 4. The motherboard. Connecting everything. Think of the motherboard as the computer's nervous system, It connects all the internal components, allowing them to communicate with one another. The motherboard houses several crucial elements, including CPU socket, where the CPU is physically placed. Memory slots. These are where RAM sticks are inserted. Expansion slots. These slots allow additional components, like graphics cards or sound cards, to be added. Power supply connection. The motherboard also includes connectors that distribute power from the power supply to various components. On the motherboard, you'll also find the bus system, which is the pathway for data to travel between the CPU, RAM, storage devices, and other peripherals. The power supply is another key element that delivers electrical power to all components. Without the motherboard, the components wouldn't be able to work together, and the computer would simply cease to function. 5. Input and output. The communication between you and the computer. A computer is only useful when it can interact with its user. This interaction is facilitated by input and output devices. Input devices. These are tools we use to provide data and commands to the computer. The most common input devices are the keyboard, mouse, microphone, and touchscreen. Without input devices, there would be no way for us to tell the computer what we wanted to do. Output devices. Once the computer has processed the data, it needs to communicate the results back to the user. Output devices include the monitor, to display visual results, speakers, to output sound, and printers, to produce physical copies of documents. Both input and output are vital to the user experience. The computer can perform a variety of tasks, but it's through input and output devices that you can actually interact with the system. 6. The operating system. The bridge between hardware and software. The operating system, OS, acts as a bridge between the computer's hardware and the software. It provides a set of instructions that tell the hardware how to interact with the software you're running. The operating system is responsible for managing hardware resources. It controls how different components like the CPU, RAM, and storage work together. It also manages the allocation of resources when multiple programs are running at once. Running software, the OS launches, manages, and closes applications. It makes sure that when you click on an application, the computer knows which resources to allocate and which files to open. Providing the user interface. The OS creates a graphical interface that allows you to interact with the computer. It's the desktop environment you see, including things like the taskbar, file explorer, and application windows. Popular operating systems include Windows, Mac OS, and Linux. Each of these operating systems has its own strengths and is suited to different types of users. For example, Windows is known for its wide compatibility with software, while Mac OS is favored by creatives for its stability and design. 7. Software, the magic behind the tasks. While hardware makes the computer function, it's software that directs its actions. Software can be divided into two major categories. System software. This includes the operating system, device drivers, and utility programs that keep the computer running efficiently. The system software ensures that the hardware components are functioning and optimized. Application software. These are the programs you use every day. For instance, word processors, games, web browsers, and video editors are all applications. The operating system allows these applications to run by providing an environment where they can access the hardware and system resources. Without software, the computer would be a lifeless machine. It's the software that tells the computer what to do with all the data it processes. 8. Communication. The internet and networking. Today's computers don't just operate in isolation. They are interconnected through networks. This allows us to share information, browse the internet, and communicate with others. The most common way computers connect is through Wi-Fi, wireless networking technology that allows computers to connect to the internet and local networks without the need for physical cables. Ethernet, a wired connection that is often used in offices or homes for fast, stable internet access. Bluetooth, a short-range wireless technology used for connecting peripherals like wireless mice, keyboards, and headphones. The internet is a global network of interconnected computers, and it enables access to nearly unlimited amounts of information. It allows us to stream videos, visit websites, play games online, and communicate with others. So, how does a computer work? It's a highly coordinated system of hardware and software that allows you to do everything you need. The CPU processes data, memory stores information, input and output devices help you interact with the computer, and the operating system ties it all together. From the simple task of typing an email to the complex process of rendering 3D graphics, a computer makes it all possible by working seamlessly with its components. Now that you know the basics, you can appreciate the incredible technology that powers the device you use every day. If you found this breakdown helpful and want to dive deeper into the world of technology, don't forget to subscribe to our channel and hit the bell icon so you'll be the first to know when we upload new videos. Thanks for watching, and we'll see you in the next video.